Hello friends, welcome back to my channel. Today we are gonna see the mole concept. So let us start with the video. So basically, without jumping directly onto the topic, we must think a question. How can we measure identities? Entities basically. So we can measure it by mass. And what is the SI unit of mass? Grams. For volume, we can use liters, while for distance, we can use meters. Moving ahead. So how to measure atoms or molecules of such smaller magnitude? Have you ever wondered this? That these are so small that we need electron microscopes to see it. So how can I measure them? Just as we denote 1 dozen for 12 items, it can be anything like 12x is equals to 1 dozen, 12 banana is equals to 1 dozen, right? Similarly, a mole is used to count entities on the microscopic level, and these entities can be atoms, molecules, ions, or particles. So, what is a mole? A mole is the amount of substance that contains as many entities or particles as there are present in 12 gram of C12 atom, which is exactly equal to 6.02 into 10 to the power 23 particles. So, the number of particles in 12 gram of C12 atom is 1 mole. And 6.023, if we go to the exact value, into 10 to the power 23, is also known as Avogadro's number or Avogadro's constant. It means that this scientist was responsible for finding out the exact and correct value. So why C12 is used as relative atomic mass? So atomic weights are an average of the relative masses of all the isotopes of the given element. The number of C12 atoms in exactly 12 gram of C12 is 6.02 into 10 to the power 23. So C12 is used as a relative atomic mass in calculation of Avogadro number. Also, most of the things are made up of carbon, and that is why C12 plays an important role here. Relative atomic mass. The ratio of average of mass of an atom of the element to the 1/12th the mass of the carbon atom is defined as the relative atomic mass of any element. For example, mass of one nitrogen atom is equal to 14 into 1 upon 12. That is mass of one carbon 12 atom. So similarly, mass of one O atom is equal to 16 into 1 upon 12. That is mass of one carbon 12 atom. Atomic mass unit can be defined as 1 upon 12 into mass of one carbon 12 atom. So this is what is known as atomic mass unit. Now, what is Avogadro's number or Avogadro constant? As I already told you previously, that Avogadro number is the number of constant particles, usually atoms or molecules present in 1 mole of the substance, is equals to 6.02 into 10 to the power 23. So, 1 mole of hydrogen atoms is equal to 6.02 into 10 to the power 23 atoms. 1 mole of water molecules is equal to 6.02 into 10 to the power 23. 1 mole of sodium chloride is equal to 6.02 into 10 to the power 23 formula units. Right? You have to identify what type of it is present, atom, molecule, or a formula particle, and then you can use atoms, molecules, etc. So how we calculated Avogadro's constant? So by a mass spectrometer and experimentally, we knew that the mass of a C12 atom is 1.99 into 10 to the power minus 23 grams. Now, knowing that 1 mole of the carbon atom weighs 12 gram, the number of atoms in it is equal to 12 gram upon 1.99 into 10 to the power minus 20. So after solving the equation, we find it equal to 6.02 into 10 to the power 23 atoms. Moving ahead, the mole concept is this, right? You can revisit this video and check out this slide because it is just a summary of whatever I have told you till now. Moving ahead, molar mass. Molar mass is defined as the mass of one mole of substance in grams and is numerically equal to atomic mass. So whatever is the atomic mass of a particle, it will be the molar mass of that particle also. So molar mass of water is equal to 18.02 gram per mole. Molar mass of sodium chloride is equal to 58.5 gram per mole. Now this can be calculated out experimentally also. Molecular mass. Molecular mass is defined as the sum of the atomic masses of all the elements present in the compound. Atomic mass of hydrogen, 1. Atomic mass of oxygen, 16. 2 into 1 plus 1 into 16. 2 plus 16 is equal to 18. Similarly, for H3PO4, the molecular mass will be 98. Here, you can, for practice, you can calculate the molecular mass of glucose and hydrogen peroxide. And if you are finding any issues, write it in the comment section. I will solve it for you. How to calculate the moles? So, calculate the number of sodium atoms in 0.1.20 mole Na, right? So 0.12 mole Na into 6.02 into 10 to the power 23 atoms is equal to 7.22 into 10 to the power 22 mole. Similarly, you can solve for K as I have shown here. Moving ahead, one of two problems are there, queries. You just solve it. If you're unable to solve, write it in the comment section. Mole calculations. Calculate the number of magnesium and chloride ions present in 0.45 moles of MgCl2. You just view it, right? You can view it completely by pausing it. Next, percentage composition. Percentage composition is defined as the percentage when mass of each element contributed in the compound. Mass percent of an element is equal to mass of an element in the compound upon the molar mass of the compound in 100. So calculate the percentage of nitrogen. So mass percent of an element is equal to mass of an element in the compound upon molar mass of the compound into 100. So similarly, you can calculate out the percentage of nitrogen. Empirical formula. Formula represents the simplest whole number ratio of all atoms present in the compound. Now, what is different from the molecular formula? Molecular formula represents the actual number of different atoms present in the compound. For example, glucose molecular formula is C6H12O6, but this empirical formula deduced from it after taking its whole number ratio is CH2O. Common, basically common. Now, here in this, we have calculated the empirical formula of a compound composed of 38.67% carbon, 16.22% hydrogen, and 45.11% nitrogen. Kindly check it out. So we finally get the formula as C1H5N1. These are some of the questions you can solve. Try solving, right? Now, if you're unable to solve, as always, write it out in the comment section. What is the percentage composition of sodium hydrogen carbonate? Just solve it, right? If you're unable to solve it, check this out again, and you will be able to solve it, right? This is completely just like sodium. How we take out the percentage mathematics is just like that. Now this is now I have to calculate this out. A compound contains 4.07% hydrogen, 24.27% carbon, 71.65% chlorine, and its molar mass is 98.9 grams. Now I have to calculate its empirical formula and molecular formula. So first of all, we need to know the steps involved in the solution. Conversion of mass percent to grams. Remember this, you have to do this. Convert into number of moles of each element. Divide the mole value obtained above by the smallest number. So this is some hint I have given you, so that you can solve it easily. And if you're unable to solve it, write it out in the comments. Stoichometry. Stoichometry and stoichiometry calculations. So what is it? Stoichiometry deals with the calculation of masses of the reactant and the products involved in the chemical reaction. But before calculation, we need to know the exact amount of all the masses of reactant and taking part in any chemical reaction, for which we need to balance the chemical equation. For example, a balanced chemical equation for the reaction is CH4 plus 2O2 plus CO2 plus 2H2O. So the coefficients 2 for O2 and H2O are called stoichiometric coefficients. Now calculate the amount of water produced by the composition of 16 gram of methane. This is the solution. Don't see the solution, first try yourself, because it's really easy. Okay, try it out. Now, moving ahead, limiting reagent, which is the last topic. The reactants which can consumed and limits the amount of product formed is therefore called the limiting reagent. For example, in the reaction N2 plus 3H2 plus 2NH3, dihydrogen is, now you might get confused, dihydrogen. Well, H2 is also known as dihydrogen. Now, H3 can be called as trihydrogen. So in the reaction, a dihydrogen is the limiting reagent because the amount of product formed ammonia is mostly dependent on the availability of the dihydrogen. So this was all from the video. If you have any queries, write it out in the comment section. Right?